All right, today we are reviewing for your test over Chapter 3, which will take place on Wednesday, the 4th of October, 2017. Okay, so the test is over Chapter 3. We've already covered a lot of the material. We're just reviewing stuff. I will be available for tutoring after school today, which is Tuesday, October the 3rd. So even if you don't see me in class today, you will see me at the end of the day if you want. Don't have to, but you can. I'll be here until 6 today. Okay, so what I've done is I've gone through the test and I picked out some problems that look like questions from the actual test to go over. Most of them are homework problems that you did in class, but you might not have checked to see if you got the right answer, or maybe you didn't solve it the correct way or the fastest way. So that's why we're looking at it here. Okay. So this was question 21 from the chapter 3. It says the motion of two people, Carlos and Diana, moving along a straight path that's described by the graph in figure 14. They want to know what the total displacement of each person during the 4-second interval shown on the graph. Okay, so if they gave me a velocity time graph, what is the easiest way to calculate displacement? Easiest way to calculate displacement if they give you a velocity time graph. Is it to use the equation? Look at the graph to figure out displacement. How do I know displacement using a velocity time graph? It's the area. Oh, it's the area. Okay. So can quickly find what the displacement of C is because it's the area right here. Oh, area. The area under the curve, which means between the line and the zero line. So for Carlos, the displacement is just going to be length times width, which is going to be 4 times 2. Which is 8.0 meters. And all of this is above the graph, right? So that means it's going to be positive. Okay? So what about for Diana? How am I going to solve Diana's? Do the same thing, except Diana's a different shape, right? Hers is a triangle. So for Diana, delta x is going to be equal to 1/2 times the base times the height. Where do I see what at? So area of a triangle is 1/2 times base times height. So for Diana, to get the delta x, it'll be 1/2 times 4 times 2. Nope, 2.5. Yeah. You do have to be exact. So 1/2 times 4 times 2.5. 1/2 times 4 is 2. 2 times 2.5 is 5. And 2 sig figs, so 5.0 meters. And it's still in the positive direction. Okay, this question was not asked in your homework, but it's still important. What is Diana's acceleration? So how can I figure out the acceleration if I have a velocity time graph? It's the slope. So that means on Diana's graph, I need to find 2 pretty points, right? So this 0, 0, that's an obviously pretty point, right? And I'm going to pick this one just because I want to. Okay? So remember, pretty points are where 2 grid lines actually match up. Don't pick it in the middle of a grid line. Pick it right where 2 grid lines match up. Okay? So the acceleration is the slope which the other way of writing that is going to be V final minus V initial over T final minus T initial. Okay? The same thing that you said, y2 minus y1 over x2 minus x1. Because the v's are the y's and the t's are the x's. Okay? So we've got acceleration equals v final. Velocity here is 1 minus v initial was 0 over t final, from the graph is right here, is 2 minus v initial, or t initial was 0. So the acceleration is equal to 0.50 meters per second squared, positive direction. Okay? All right, number 17. We have a bus traveling at 30 kilometers per hour east, has a constant increase of speed of 1.5 meters per second squared. They want to know what the velocity is 6.8 seconds later. So what is this telling me right here? This 30.0 kilometers per hour east. Velocity, is it the initial velocity or the final velocity? Okay, so given my V initial is 30.0 kilometers per hour. East means that this is going to be positive. Okay. As you can see, I have kilometers per hour, I have meters per second, and I have seconds, which means I need to convert my kilometers per hour. So I've got kilometers, but I want meters. So get rid of kilometers, put it on the bottom. Go to meters on the top. Okay? On the bottom, I have hours, but I want seconds. So hours on the bottom. To get rid of it, I put hours on the top. And I can put seconds on the bottom. Okay? There are 10 to the 3 meters in every 1 kilometer. And there are 3,600 seconds in 1 hour. You could have, if you wanted to, done 60 seconds in a minute and then 60 seconds in an 60 minutes in an hour, 60 seconds in a minute, and gotten the same answer. Okay, so now I got to go over to my calculator. Okay, so I multiply straight across on the top, and I get 30 times, and it'll be 10 to the third. So on the top I have 30,000. On the bottom, 1 times 3,600 gives me 3,600, right? Okay. So I'm going to do top divided by the bottom, so that's 30,000 divided by 3,600. And you get that the acceleration, the V initial is going to be 8.3 repeating meters per second. Now, when I go to solve this problem, I'm going to use the 8.3 repeating. I'm not just going to use my rounded 8.3 because I don't round until the end of the problem. Okay. So now we have V initial. What is this 1.5 meters per second squared? Okay. And is it going to be positive, negative? Okay, it's positive. Okay, and then 6.8 seconds, what is that? All right, that's our delta t. All right, our unknown, they want to know what the V final is. They asked what is the velocity, right? Okay, so I have V initial, I have A, and I have delta t. I'm looking for V final. Which equation fits for that? Equation 1. So equation 1 is V final equals V initial plus A delta t. We go to solve. V final is my unknown, so I leave it as V final. V initial was 6.8, or I'm sorry, I'm reading that wrong. It's 8.3. 8.3 repeating plus 1.5 times 6.8. Okay, so I go back over to my calculator. Notice how I already have the 8.3 repeating in the calculator? I don't have to retype it or anything. I have that as my first number. I'm going to hit plus 1.5 times 6.8. Hit enter, and I get an answer. So my V final is equal to 18.53 repeating. Okay, how many sig figs did I have at top? 2. So that means that this is going to round to V final is how much? 18.5. There's my second sig fig. The 5 makes it round up. So we end up with 19. What unit goes on velocity? Meters per second. And what direction is going to go on it? East, because they told us the positive direction is east. E for east. Okay? Do not forget to put your units and your directions. Okay. New problem. Skateboard is moving at a constant speed of 1.75 meters per second. So what is that going to be? 1.75. Okay. So it's moving at that, and it's going up an incline. So that means up is positive, right? Okay. And that's going to be velocity initial. These are my givens. Okay. And it's going to slow down with a constant acceleration of negative 0.20 meters per second squared. It says how much time passes from when she begins to slow down until she begins to move back down the incline. Okay, so when I get to the top, how fast am I moving? Someone said it. I heard it. I think it was on the right side of the room. Yeah, when I get to the top, my V final is 0. Okay, remember, as I go up, I'm moving in the positive direction. As I go down, I'm moving in the negative direction. So if I get all the way to the top, just before I start going down, I have to hit the magic number that's between positive and negative, and that is 0. Okay? The unknown is time, delta t. All right, which equation are we going to use? We have V initial, A, and V final, and we're looking for delta t. Equation 1 will work. So V final equals V initial plus A delta t. We go to solve. We have V final is 0 equals V initial is 1.75 plus A is a negative 0.2 times delta t. Okay, so what is this 1.75 doing to the delta t? Is it adding, subtracting, multiplying? This 1.75 here. It's adding. So the opposite of addition is 2. So minus 1.75 on both sides. I got minus 1.75. Ooh, that's a 1.7. 1.75 is equal to negative 0.2 delta t. What's the negative 0.2 doing to the t? It's multiplying. The opposite of multiplication is to divide. So now I go over to the calculator, type in 1.75 divided by negative 0.2, enter. Ooh, I forgot to put negative 1.75 divided by negative 0.2. So that just means that I should have gotten positive 8.75. So why do you think I went ooh whenever I got my answer? No, because I got a negative for time. Does negative time make sense? Because time moves in the positive direction. That's right. All right, how many sig figs did I have up at the top? Well, I got 2 on my acceleration. So that means I'm going to round my answer to 2 sig figs. This is going to make it 8.8. And the unit is seconds. Okay. All right. An airplane is accelerated uniformly from rest at a rate of 5.0 meters per second squared south for 14 seconds. What final velocity did it attain? You know, I think we've done 2 problems just like this already. We're going to skip this one. It's looking for V final. They gave you V initial is 0 whenever it says it's at rest. I think that was what I wanted to remind you of. If something is at rest, how fast is it moving? 0. Okay? All right, a tennis ball is thrown straight up with an initial speed of 22.5 meters per second. So what is that going to be? VI equals... Yeah, up is positive, we typically say, right? And it says it's caught at the same distance above the ground. The question is, how high does the ball rise? All right, so we're on the planet Earth, so we know something about things that are free-falling or being thrown through the air. What did we know? That's right. The acceleration is going to be from gravity, which is negative 9.8 meters per second squared. The negative means that it's going down. Good. Okay. Another thing, when I get to the very top, how fast am I moving? That's right. V final at the very top is going to be 0 meters per second. Okay, the unknown that they wanted us to figure out is how high does the ball rise? So what is that going to be? That's right, it's the x. The x is the distance or the displacement. If I know the distance that it went and I know the direction, it's called displacement, right? All right, equation. So I've got V initial, A, V final, and delta x. So V final squared equals V initial squared plus 2A delta x. Okay? So we plug it in. V final was 0. V initial was 22.5 squared plus 2 negative 9.8 delta x. Okay, let's go and simplify. So we got 0 equals 22.5 squared. I have to go over to my calculator for that. $506.25. And then 2 times negative 9.8 is going to be a minus. And 2 times 9 is 18. 2 times 0.8 is 1.6, so it's negative 19.6. All right, I need to get delta x on a side by itself. So what is the 506.25 doing to the delta x? It's adding. You see how there's a plus sign in front of the 506.25? I know it's hidden, right? But it's a positive, so to get it onto the other side, I have to subtract. So we subtract 506.25 from both sides. Okay, so now I have negative 506.25 equals negative 19.6 delta x. Okay, what is the negative 19.6 doing to the delta x? Yeah, it's multiplying. The opposite is divide. Okay, so I come over here to my calculator, and I have negative 506.25 minus, or divided by negative 19.6. I get 25.82908163227. So how many sig figs did I have? I only had 2 on this one? 3 on this one? Okay, good question. This 9.8, don't use it to calculate your sig figs.
3.
So we're going to use the numbers that we're actually given was 3, so we need to round this to 3 spots. So that's 25.82. The 2 is going to make it stay at 8. So delta x is 25.8. This is displacement, so what direction does it have? Well, we have to think. Remember, equation 3 doesn't give us our direction. So did it go up or did it go down? Well, let's look over here. It says, how high does the ball rise? It went up. So make sure that you're looking at the question to figure out your direction if you use equation 3. All right. It says, how long does the ball remain in the air? Okay, so the unknown is time. But before I do any of that, let's go and rewrite our givens for this part of the problem. So we know that the V initial was 22.5 going up, right? Okay? We know that the acceleration is how much? Negative 9.8 meters per second squared. Okay? We know the displacement is how much? Oh, trick question. That 25.8 was only halfway. This is how long does it stay in the air total? So the 25.8 only got it to the top. It didn't measure it coming back to the bottom. So the way I have to look at this is I started at like ground level and I threw the ball up, right? How long does it take to come back to ground level is what they're asking. So delta x in this case, I started at, say, a meter off the ground, and I ended at a meter off the ground. So how far do I travel then? If I start at 1 and end at 1, how far do I travel? None. So that's going to be 0 meters. Because I landed at the same spot I started. So I might have traveled somewhere in the meantime, but at the end time, I'm back where I started, so my displacement is none. Remember, displacement is your final position minus your initial position. So if they're the same spot, it's 0. Okay? One more thing that we can do. One more ungiven given. Do y'all know what V final is? V final is not 0. Okay, so I started throwing it 22.5 meters per second up, right? Gravity worked for however much time it took to get to the top to get it to 0, right? Gravity then had the same amount of time to accelerate it down, right? Did the acceleration change? No, it stayed the same the whole time. So that means that the final velocity, since it was caught at the same height, is going to be just the negative of whatever the initial velocity was. All right, so we've got a lot of given, and only one of them was given, right? It's all situational stuff, so make sure you're reading the questions carefully. The unknown, we are looking for delta t. So which equation will get us delta t? Yeah, so since I gave y'all all this extra given that was not technically given, we can use equation 1. If I didn't know that V final was negative 22.5, I'd have to use equation 2. If I was using equation 2, I'd have to solve a quadratic equation. We would get the same exact answer, but it's a little bit harder from the algebra standpoint. So the equation we're going to use is equation 1, which is V final equals V initial plus A delta t. We can solve. V final is negative 22.5 equals V initial, which is a positive 22.5, plus A, which is a negative 9.8, times delta T, which is our unknown. All right. So what is this 22.5 here doing to the negative 9.8 delta T? It's adding. There's an invisible plus sign here, right? So the opposite of addition is to subtract. So minus 22.5 minus 22.5 should be negative 45 equals negative 9.8 delta T. What's the negative 9.8 doing to the delta T? It's multiplying, so we need to divide by negative 9.8. That's when I come over to the calculator and I do 45 divided by negative 9.8. And I get negative. Oh, no. I did it again. I forgot my negative. But as soon as I saw this negative, what had happened in my brain? Time can't be negative. I've got something wrong. So I have to look back, and I see that I left out a negative. A negative divided by a negative is a positive. So that should have been delta T is equal to positive 4.59 seconds. All right, so that was 44. There was a C? There wasn't no C on 44. All right, I think I've got time for one more question, so I'm going to pause and find one more question real quick. All right, we are back. People in the class know that that was a longer break than what you experienced on the YouTubes. And to answer the question that someone just asked in the class, yes, this will be linked on the website. You can go to my YouTube channel, which is in the links on my website, which for those who can't remember how to get to my website, just type my last name, Larue, and type the word life. I'm the first link in the Googles. Okay. All right, so the airplane in figure 18 starts from rest. So what kind of given is that? Good. Whenever I see rest, I should know that something is 0. So in this case, it's starting at rest, so that's V initial is 0. It accelerates east at a constant 3.00 meters per second squared. So since it said accelerates, I bet y'all know that's the acceleration, right? And it took 30.0 seconds before leaving the ground. What is 30 seconds going to measure? Delta T. The unknown. For letter A, it says, what was the plane's displacement? Man, they spelled it out for you. They didn't even make y'all a guess. All right. What equation is going to work for this one? Okay, equation 1 doesn't have delta x in it, so that's bad. Equation 3 has delta x, but it also has v final, which we don't have, so that's a bad one. The equation we're going to do is equation 2. So delta x equals v initial delta t plus 1/2 a delta t squared. We go to solve. Delta x is our unknown. The initial was 0 times delta t is 30 plus 1/2 times a was 3 times 30 squared. So I just have to put this in the calculator now, right? So I got 0 times 30 is 0. So do I even need to put it in the calculator? Nope. And then I do point 5. 0.5 is the same thing as a half, right? Times 3 times 30 squared. Enter. 1350. It says delta x is equal to 1,350. How many sig figs did I start with? 3. Is this 3 sig figs? Sure is. What unit goes on displacement? Meters. What direction is positive in this problem? Accelerates east. So east is positive, so positive means east. All right, so that's that one. And then letter B, how fast was the airplane going when it took off? So the new unknown is V final. Well, this one should be easy. Just plug it into the first equation. V final equals V initial plus A times delta T. So V final equals 30 plus 3 times, wait, V initial was 0. My bad. 0 plus 3 times 30. So V final is equal to 90 meters per second. Is that right? No! It's not right.
Oh, you forgot the dollar?
What do I have to put onto all my numbers? Check? Check sig figs. 90.0 meters per second to get to 3 sig figs. What else am I missing? Direction, east. All right. So remember, when you're taking your test tomorrow, you need to check your sig figs. You need to check your units. Hey, y'all need to check your direction. The other thing you need to remember is tomorrow is your notebook check. All of the assignments are on the website. Again, I'm going to go to the website for those of you who don't know how to do it. You type into the Googles LaRue, that's Larue, and life. Click Oak Cliff Secondary, click your physics class, hit see all on your upcoming assignments. All of the Chapter 3 assignments and the lab are due to be checked tomorrow. The other thing that you can see on the website is on that first thing, it says links. If you click on links, you'll see Mr. LaRue's YouTube page. Once you click that, you'll see all sorts of things for this. It'll be the first video that I have uploaded today. All right, that is all. Have a good day. Oh, remember, at the end of today, you can come to tutoring if you need to.